Thank you very much, Sam. Good afternoon. I'm going to talk about something a little bit different, perhaps. Data is the lifeblood of the modern business. Data-driven decisions are improving customer satisfaction, driving innovation and improving services, and hopefully contributing to the viability of the company, of course. How can you become a data-driven digital business, making use of data to make informed decisions about your business? What do your customers do? What do they want to see from you or use from you? So in this talk, I'll explore the challenges associated with acquiring the right data in the right way in order to better support your operations. And hopefully you'll find some of the themes I present here useful. So thinking from the perspective of a content-rich organisation, say a publisher or else a science-based organisation acquiring and generating content for its consumption, then we want to know more about what makes content work, not work, perform, be useful. What do these questions even mean? And once we can understand the question, how do we go about figuring out the answers? Statistics and complex mathematics lie at the heart of number crunching for machine learning and, of course, much data analytics. How good is your data? Are you using the right data in the right way? It's a bit more complicated than just acquire all the data and let the machine or black box do its thing. I think it's a recurring theme that we've had from today. And that's the end of the statistics lesson, okay? We're not doing a maths course this afternoon. So consider the flow of content through your organisation from origination all the way to consumption. It can be touched in many ways, maybe by a human, maybe by machine, maybe by multiple rounds of edit, enrich, review, edit, enrich, review. Once it leaves the content factory, it heads out to be consumed in some way. Maybe you provide the content directly to end users, maybe it's embedded in a third-party product, service or application. Maybe the book, journal, newsletter is distributed by other intermediaries. Maybe it's on paper, a test, an exam, and so on. All of these systems and touch points on a content item's journey have signals and data that can be mined to help answer tricky questions. I'd suggest there are questions business users really want answered, but are too afraid to ask, or at least been trained not to. And there are a number of examples on this slide. How do users find us or the content is relatively easy on a website with Google Analytics plumbed in. That's a relatively standard query. But what content produces the most effective outcomes is a good deal harder. You may well have the metrics to determine what quiz questions students most get right or wrong, but that doesn't tell you whether it supports a long-term learning outcome or not. And this data may well come from an entirely different source or an organisation. In fact, we heard a presentation about learning systems and content outcomes yesterday. During data analysis, technology need to work out if the necessary data items exist, and if they do, where can they be sourced from? In acquiring data from multiple sources, there are a number of factors that have to be resolved. Does it even exist? How regular is that data? How accessible is it? What security and privacy factors have been accounted for? Who owns the data? Given that the data is likely to be in multiple different systems, at least, then some form of collection, normalization, and cleansing is required. In fact, this area is one of the most crucial aspects of any data analytics activity. How good is my underlying data? If I'm going to try and draw insights from it, is it accurate, representative, or even the right data? Time after time, we hear about lessons from data analytics activities where a greater emphasis on investment on data quality would have made downstream work much better and faster. This is perhaps the unsexy part of data analytics and machine learning. To help us, we developed the Content Insight Wheel. At the center is a content object, and around the edges of the spokes are discrete themes. We've organized these themes by a number of perspectives. The wheel is designed to capture the full life cycle of any given content object. So, for example, the finance perspective includes two very simple and obvious themes, cost and revenue. They may be simple on the surface, but are clearly more complex the more we drill down into them. And the same applies for most every other theme. So where does the underlying data come from? Well, we all know they're in databases and weblogs, right? Let's consider our first worked example. What return on investment do we get from our licensed images? If we think about what that simple sounding question really entails, we quickly realize how much disparate data we need to acquire in order to answer the question. And this is where the Content Insight Wheel can help. If we consider that the content object is the image in question, or rather very many objects and images, in order to work out an ROI, we need just the cost and revenue only, surely. But license cost and sales revenue does not alone provide the ROI. How much time and effort was expended on working with the assets? How were they incorporated into a product or multiple products? Workflow systems may have the tracking data and time taken in order to perform some estimates of time allocated. The product packaging manifests or management systems may have data on where the images were deployed. However, even here it becomes ever more complex. In how many cases an image acquired with one name and then used and reused with different file names in each reuse? Boston Tree of Liberty, for example, becomes picture of tree or figure 3 or image on page 96, and any association with the incoming file is broken. And the sales data may come from multiple different channels and formats, distributors and the like. One of our clients used an image of a tiger, not this one, in many of their products, and suddenly realized it was everywhere in a clear case of overuse. It was not a case of highly cost-effective reuse and efficiency, but overexposure. There's a balance to be played. How can you use data? There's a balance to be played, and how can you use data to manage that in a less obvious scenario? A more typical situation that publishers find themselves in is in multiple acquisitions of the same asset, and we see this time and time again. Different departments or business divisions of the same organisation acquire the same image and use it rather than one already sourced. There are several problems with this. The first time the asset is acquired, it probably underwent a negotiation for use and reuse. The next time it's acquired, a similar process should have been followed. The third time, the same thing happens. This could be compounded by acquiring the same asset from different sources with different rights and permissions, as well as different identifiers. This means that the same asset can undergo the same validation and clearance processes multiple times. Effective rights use and management, together with search and discovery across silos, can result in more efficient businesses. And oftentimes the extent of these replicated assets and the wasted additional efforts are entirely unknown. Better understanding your data will throw up issues such as this. I could have substituted this picture with pictures of my dog in the themes of yesterday's presentations, but decided not to. So where does the data come from? As already mentioned, there are the obvious places, weblogs and analytics, commerce systems, cost of acquisitions and so on. However, these alone do not provide a comprehensive and accurate set of data. Content management systems data may have useful asset-related information, such as workflow systems, as do workflow systems. However, some of the really valuable data may well be locked in spreadsheets, and some of these spreadsheets could be shared via email, making it hard to establish the authoritative source over time. Some organisations drive their entire workflows, resource planning and status management in such spreadsheets. How can you identify the authoritative sources, create links and extract that data on a reasonable frequency, reliably? So factor up this and similar issues for each and every data source, provide connectors, processing pipelines and filters, and we're moving very quickly into highly complex, intricate, expensive and potentially unreliable territory. Data quality is the hard graft of data analytics and is a reason why it's so difficult to go beyond the pilot stage. Data provenance is also critically important, as actually we've been hearing today. In acquiring data for analysis, it may well have had to undergo some form of transformation or normalization. Tracking these may be essential when downstream analysis throws out some interesting facts which require investigation. Notwithstanding the complexities, once we have our data sources accessible, we need to suck in all the data, store it and make it available. And this is traditionally the world of the data lake. In the data lake, we store the data we want to work with either in its source format or transform to make it more usable. There may be a temptation to acquire and store as much data from as many sources as possible. After all, if I have all the data, I can do any kind of analysis I want, right? Actually, I would argue we should be more focused. Reliably acquiring data and managing it in the data lake is an essential foundation for good analytics, but it also takes time and effort. And also, we don't want our data to degrade into a data swamp. In any event, now we have our master data store, we can make it available to different types of consumers who may all have different tools, methods, and perspectives. Different data access patterns may well require alternative data storage, such as column-centric stores for optimizing reads on the fly, for on-the-fly aggregation, or the pre-calculation of aggregated measures for more static data. Reporting users will want to use familiar tools. So often this will involve delivering to an existing data mart so that there are no downstream reporting changes. In fact, one of our big data projects had to do exactly this and use the blue-green pattern to allow for the warehouse to be built from scratch whilst users were actively running reports. The data analyst will occasionally want to go back to the raw source data, and data scientists always want to go to the raw data. An example of the different possible approaches to data analysis can be found in the use of approximate queries. Approximate queries are an interesting area of research. How do you really need to have an accurate answer? Sure, in some circles, such as the amount of regulatory capital a bank needs to hold to comply with the Basel Accord, then you need to be diligent. But elsewhere, it might not be so critical. For example, whether the average journey time was 24.79876 minutes or around 25 minutes doesn't really matter. Although on my train, when we go 50 minutes, 55 minutes, an hour and 5 minutes, an hour, it really does matter. They are highly applicable for interactive analytics, where you're willing to trade accuracy for significantly faster response. Approximate queries rely on statistical techniques, in particular sampling, to avoid processing the full data set. Dedicated approximate query engines will also estimate their margin of error to keep the user informed. And ultimately, the goal is to provide good quality analysis to support the business decision makers. So we said that finding and capturing all these data sets in a reliable and controlled manner is essential to support the business, but it also requires a level of effort and complexity that can be daunting or prohibitively expensive. There are strategies that can help reduce the burden, and these can include the really obvious. Only take the data you really need and do it in a systematic and structured way. Use whatever tools may be available to you. Use open standards and open architectures wherever possible. Apply open ontologies. Above all, make sure you maximize your future freedom of action. Do not constrain yourself to future changes or additions. And at Ixxus, I like to think we do all of these. So what can we do to reduce the cost and better focus the effort? As we've said, look in the right place, which is not always that easy. Model the data effectively. Connect to the data sources and acquire the right data with authority and compliance. Move the data to the data lake and store and anonymize, protect, and secure. And use it to start analytics and visualizations. Don't underestimate the challenge of acquiring data from multiple sources, even if you own them. Simply moving huge amounts of data around is a significant challenge. And this is where the content insight wheel can help. We can use it to help analyze the questions and identify the areas to find the relevant source data. Simply by zoning in on only the relevant sources reduces overall effort, complexity, and significantly increases the chances of success, and especially within reasonable timeframes. One of the challenges in data requirements engineering is exploring an unknown space with multiple parties. The typical disconnect between business and IT is often a contributing factor to unsuitable reporting systems. Well, actually, it's probably a contributing factor to just about everything. And Helen referred to the gap earlier today. The reason is often that neither party has a shared understanding of the project, and this is often due to a lack of time spent by both parties trying to understand the viewpoint of the other team. Consequently, we need to rely on a number of different elicitation techniques, such as surveys, interviews, observations, workshops, and so on. And as such, the guided analysis includes surveys, as in the screenshot here. Couple this framework with a set of tools to extract and process data, categorize the questions, and the ability to crunch data reliably starts to increase. Let's just look at another example. Content recommendation. Again, content recommendation has been much discussed over the last couple of days. So people like you are also interested in some other content. So the assumption is you should see it too. When this works to your liking, it's extraordinarily powerful, and when it doesn't, it's extraordinarily irritating. So what factors are at play? How do we even categorize people to be like me or like you? Machine learning is driving this area forward at a remarkable pace. And as we all know, machine learning requires data and lots of data. But which data and where do we start? Let's say that we can get some signals about a user's liking for some content. It could be as simple as a like on a piece of content, or more complex, as in saving items to a work list or sending a link or opening many times over. We can cluster users around their aggregated usage data and then say, this group of users is, we can cluster this group of users in a cluster that includes you. We can then say these users who are similar to you also like this content over here that you might not have considered. Of course, Netflix, Spotify, Amazon, and so on are the exemplars of this capability. And the content insight wheel helps with categorizing the problem and assists with determining the right data sources. A standard method of improving user experience and overall performance is to try different presentations or modes of interaction, often known as A/B testing. Testing how good your content is may involve some form of dynamic testing. Classical A/B testing is obvious. More complex experiments might be combining different content pieces with different designs and user journeys in order to see what best sustains a user. This approach will generate data of different types, and in order to analyse effectively, we need to capture the right data. Taking this further means we want to conduct deeper experiments. Content Insight Wheel can help focus our attention, and we need to consider data associated with packaging, performance, and outcomes, which are often quite difficult areas, as well as aspects of the user and their usage behaviours. In this particular case, we can ignore costs of acquisition and workflow complexities. So in summary, what are the steps to success? What's the question really all about? What are the areas that need to be covered in order to provide the optimal answer? Understand the data sets and what are the data characteristics and source types. Now access the data sources and collect the data, taking care of provenance and compliance. Use the data to test and experiment. You may well need to iterate and improve the overall data quality and the focus, and don't overcomplicate initially. So above all, focus. Collect only the data you need. Pick the questions you want to answer, as different questions require different tactics and different metrics require different experiments, and iterate. My point is to focus. Don't boil the ocean, otherwise you'll never get your analytics program off the ground. Thank you.